But Hi everyone, thanks for being here today. Really appreciate the opportunity to come up here and speak. My name is Fritz Ogden. I'm the Chief Executive Officer of Nexus Reliability. And all throughout this presentation, I'd really like you all to keep in mind our mission statement, is that we use big data to make it possible to convert small actions and provide big returns on investment. This is the Amazon Alexa, a product that I'm sure we're all familiar with. And it's a fantastic example of how business to customer and Internet of Things products are paving the way for industrial adoption or business to business adoption of these kinds of technologies. The app called Rain Machine allows you to water your front lawn from the comfort of your home lawn chair. You just use your voice and ask it to water your lawn, and that connected technology provides you the ability to remove the labor from a common activity that we all have to do. And this is really leading a lot of people in the professional space to wonder, why can't I have technology like this at work? It's really convenient and it saves me a lot of time. And if I had to water 1,000 lawns a day, it would really save me a lot of time. And this is a fantastic example of the potential benefits that growing cloud technology can bring to industry. Because the business to consumer market is already flooded with these cloud-enabled products such as the Alexa, developers and product companies are helping the cloud to grow by leaps and bounds. And with that in mind, we want to go where the ball is going and not where it is now, by focusing on business to business or industrial adoption of Internet of Things connected technologies. Before we get into what we do, this is who we are. For the last 4 years, I have been working at a reliability engineering firm as a research and development lead, focusing on industrial lubricant analysis and how it benefits machine reliability. My older brother, Chas Ogden, for the past 7 years, has been working as the chief technical officer of an industrial reliability software development firm that has specialized in any number of sensor development projects and integrations using connected technologies. And Steve has a really robust background in mathematics, physics, and data science that makes him a really powerful team member. Excuse me. Really powerful addition to our team and well equipped to handle the challenges that big data analytics brings. And this is what we do. Our product is called the Nexus Connect, as Mandy mentioned in the intro. It's an all-inclusive software platform that allows autonomous data collection, processing, and visualization that makes a giant mess of numbers into actionable intelligence that enables people to make better business decisions. In short, it's like having an engineer that babysits each and every piece of heavy equipment 24/7, 365. There's several parts to this system. First of all, the sensor data. Our platform is what's called sensor agnostic. So it has the ability to easily and seamlessly integrate data from aftermarket third-party sensors, as well as any other kind of on-platform sensing technologies that are already included in, say, an electronic control unit for an engine. Our gateway device provides the ability to gather all that data in one place and pre-process it using a technique called edge processing. This edge process data is then transmitted via the gateway device up to the cloud. Once it's in the cloud, we can apply advanced analytics to it and organize it as we see fit in order to turn that jumble of data into actionable intelligence, providing those small actions that provide our customers the large returns on investment. And finally, where the machinery connects to the human interface is through the user interface. Our web portal provides a single, easy way to log in and see an entire fleet of machinery, no matter if it's different or similar in multiple locations in a single location, and easily and securely use that data to make those better business decisions. And I'd like to take a moment to see if anyone recognizes this picture. This is a picture of the Deepwater Horizon oil rig explosion that happened in 2010. This disaster cost 11 human lives, caused 17 injuries, and caused untold billions of dollars in environmental and economic impacts. After the fact, an in-depth study was authored to help determine the root causes of this tragedy. And it was determined that flawed human input to purposefully circumvent safeguards contributed greatly to this disaster. This is unacceptable in this day and age, and with our technology, it was 100% preventable. With multiple data sources on different pieces of that rig corroborating one another, we could have provided better insight that it was not, in fact, the safety interlocks malfunctioning, but they had a real problem that should have been addressed. We could have saved those lives. We're looking to infiltrate 3 key primary vertical markets to help grow our business. First and foremost, the industrial space includes mineral processing, oil and gas, that sort of thing. Energy production includes renewables such as wind and solar, as well as traditional coal-fired power plants. And the healthcare industry, specifically the medical device manufacturing industry. All 3 of these are really ripe for innovation in the connected technology space, and we see a fantastic opportunity to get our foot in the door and help become the new standard in connected technologies. This graph was authored by Cisco in 2018. It uses a metric called compound annual growth rate to predict the growth of the connected technology or Internet of Things market over the next several years. As you can see, although it's blocked out by this thing here, excuse me, a significant portion of this market growth is captured by our 3 primary vertical markets. These account for over 1 billion connections and additions to the IoT market over the next several years. And that's a lot of opportunities to apply the Nexus Connect platform and use that big data to develop those small actions and get that big return on investment. So in our professional experience in the industrial marketplace for maintenance, we've identified 3 specific key maintenance challenges. First of all, fixed maintenance budgets mean that industrial maintainers end up playing a game of whack-a-mole. They fix stuff when it breaks, and they don't have a whole lot of a great way to predict when things are going to fail besides maintenance schedules. So our technology uses past data and real-time machine health metrics to help predict the future and figure out when things are going to fail so that you can conduct preventative maintenance before they become really big problems. Legacy systems refers to the fact that many of our plants that we have experience working on are centered around technology that's an equipment that's 30, 40, even 50 years old, and it's cost prohibitive to replace. So any system that helps connect machinery to its operators needs to be able to easily and seamlessly integrate those aftermarket or third-party sensing technologies to bring that old equipment up to speed and get that data collection to modern standards. And last but not least, dangerous conditions. Anytime you send an operator or maintainer into, say, a confined space or any kind of machinery to check on something, you're exposing them to potentially hazardous conditions. A great example that we all know of is asbestos. It's impossible to completely remove the asbestos from any of these plants. And so anytime you're sending a worker in there, you're exposing them to potentially a harmful carcinogen. So these are several examples of industrial customers that we think could benefit from our technology. Sibanye-Stillwater's a Montana-based platinum producer that spent $170 million on maintenance last year. Using a conservative 10 to 12% estimate of what our technology can bring them, that comes out to be approximately $20 million saved last year alone. Furthermore, Cleveland-Cliffs is an iron producer in the Rust Belt, and over several facilities, they spent $750 million on maintenance last year. Using that same estimate, that's $90 million in a single fiscal year. Finally, U.S. Steel Corp, another iron producer in the Rust Belt, spent $694 million on maintenance, and that comes out to $83 million on maintenance. So as you can see, these 3 customers alone could benefit from adoption of our technology and save approximately $200 million last year alone. So this is where we've been and where we're going. We earned our first revenue in August of last year, and we launched a successful pilot with a Denver-based partner in September. Our proprietary communications protocol was tested and verified in November, which is critical because it's an integral part of our technology and a really robust way to get data up to the cloud in thanks, Fred. In difficult situations, really provides a competitive edge. In March of this year, excuse me, we were winners of the Southeast Wyoming Innovation Launchpad Challenge, and we were really excited about that. And before we go any further, discussing, in fact, the reason why we're on Zoom today, uncertainty due to the COVID-19 virus. Despite this pandemic affecting us in serious ways, much like any other small business in the world right now, we're optimistic that we can have installations and evaluations of future pilot projects completed by the end of this year. At the beginning of 2021, we're going to be looking for additional major investment in the form of a Series A fundraise that will help us to commercialize and grow a business in a big way. Now, most importantly, how is this going to affect Wyoming? We're going to be at the forefront of the modernization of Wyoming's economy. Using data processing and software is really one of the biggest growing markets in the world right now, and we're really committed to Wyoming. Our technology revolutionizes how maintenance is managed and increases the standard of worker protection in a variety of industrial environments. And we all grew up in Wyoming, in Laramie, as a matter of fact, and we really like the idea of staying here, creating jobs, and having a great opportunity to help the local economy grow.
30 seconds.
In our professional careers, we have the ability to hire, train, and UW alumni students and sponsoring student projects, which we've done in the past. And so we're asking you to take this opportunity to put your vote in the form of a small action that will have a large return for Wyoming's economy in the near future. Thanks for listening, and I'm available for questions.
Thank you, Fritz, and thank you to the NexRel team. We'll do our silent language round of applause. Thanks so much for being here and preparing that for us. We'll kick it over to the judges, and I would just ask if you could stop sharing your screen so that we can see each of the judges as they're talking. That would be great. And then audience, keep in mind, if you have questions for NexRel, go ahead and send them through the chat function to send questions here, and we will move those forward either in this time of 10 to 12 minutes or following the presentation so they can hear your questions as well. And so with that, judges, who wants to kick us off? Okay, Stephen, you'll go first, and then Spencer will have you go next.
Okay, thanks. Nice slides that clarified quite a few things, so we appreciate that. I wonder though if I'm trying to get a glance at what the company looks like in the actual product shipped. Evidently, a lot of software, but what does your pilot look like? Did you attach to existing sensors? Where's the software? Where's the machine? Where's the visualization at? Could you describe the pilot in just a little bit more detail?
Sure thing. So this pilot was focused on a diesel efficiency improver device that already had all of the sensors that it needed on board. And what they needed was the ability to get that information up to the cloud. So it was a test for a prototype of our physical device, which is our network access device, which is the gateway. So by attaching that to the pre-existing sensors and technology, we were able to pipeline all of that data up to the cloud where our software could process it and visualize it. So the software exists in the cloud, with the exception of a small amount of it being on the physical network access device. Thanks, Stephen.
Yeah, who interpreted the data? One real quick follow-on. Who was looking at the data as it was visualized then?
That was the user interface that we provide to the customer just gives them visibility over their equipment. So they can look at all of the data feeds and observe trending and historical data. So the owners of the devices were looking at the...
Okay, thank you.
Oh, I did the thing where I was muted and I tried to talk. Okay, Spencer, you're up. Man, I was doing good. I made it till 1 o'clock before I did that. Usually it's a regular. Okay, Spencer, you're up next.
So yeah, I've worked actually as pretty much in reliability engineering for 8 years. I started my career at Laramie River Station, and I'm currently working for Tri-State at Craig Station in Craig, Colorado. So I've dealt a lot with a lot of the data you're talking about, a lot of different softwares. There's a lot of different approaches. And I was looking through your competitor list. Recently, our company started what's called a Fleet Monitoring Acquisition Center. And it's a big thing that companies are doing, where you essentially have a headquarters and you can just have a couple guys in a room with a bunch of screens looking at all these models and stuff that predicts what's going on and essentially sifting through the data. The company we're using is GE. I've probably heard of them. They make software called Predix, and we're using their advanced pattern recognition to sort through a plethora of data, whether it's vibration data, lubrication data, continuous data, and incremental data like lube stuff. So that's a huge competitor I did not see. Have you guys heard of Predix, and how would you differentiate yourself from large established companies such as that?
No, I was not aware of Predix specifically. Chas might have been aware of it. He's very much in tune with our competitors, and he enjoys looking at things like that. But our plan to differentiate ourselves is really not so much to focus on the development of new predictive analytics technologies, but really to become the standard in data transmission and collection. So a lot of those newer technologies rely on manual inputs, people going out and taking measurements, inputting things, having field engineers do things, and we're all about automating that whole process to reduce the human error involved and reduce the labor involved.
Automating like the data integration into one location.
Exactly.
Yes.
So,
and that I can tell you from experience, that's one of the biggest struggles. I mean, even GE with Predix, it has not been what I would call smooth. In fact, sometimes maybe we've even felt like a beta test. And so I do think that although there are competitors out there, I think there's still opportunity to differentiate yourself if you can figure out that, because you've got data coming, like you said, from all these different legacies, and it's very complicated to integrate, 1990s type software versus 2020 software and all bring things into something. So very interesting.
Yeah, exactly. And if you'd like to learn more, Chas can speak to that more in depth, but that's something that we're really proud of, our ability to get everything speaking the same language, so to say. And it's a key part of our system.
Great, thank you.
Great. Chas, did you want to say something too? It looks like you started in. If you want to follow up, go ahead, and then we'll go to Walden next.
Yeah, real quick. So Fritz touched on it, but the idea here is to develop a common platform to either make dissimilar SCADA systems talk with each other, or replace legacy systems and bring everything into a common database that can then easily connect to Predix or Watson or Wonderware or any system that you need. Put it all on a common platform.
Great. Okay, Walden, go ahead with your question.
So we'll build on that a little bit, but so right now, is it built in a way that it's an open source API so that we can push it out to other platforms, or is it built where you guys are a standalone like device and platform that nobody can really access?
The idea is to
Go ahead, Chas.
Okay, the idea is to start focused on a single endpoint system. So the gateway device, for example, that collects the data and transmits it is controlled by us, but it would talk to something in the field that provides the data or sensors. And then as the platform matures and gains more more of a following, if you will, the idea would be to open up and provide an SDK, a developer toolkit for our API.
Yeah. And so we have a client out of Germany that does something similar where they transmit a lot of data from machinery from basically Caterpillar or Boeing or whatever all the way up. But something that I noticed that they started to shift to, which I don't know if you guys have explored yet, but basically being able to do GPS monitoring of everything too. So you can basically geofence areas and see where your machinery, equipment, all that stuff's going, then actually be able to communicate back as kill switch mechanism, stuff like that. So have you guys thought about doing stuff like that?
Yeah, we have. A lot of our early pilots or customers, prospective customers, deal with large stationary equipment, so it's less of a concern for us out of the gate, but it's something it's on the roadmap.
Yeah, cool.
Great. Other questions from the judges, or if we have audience questions too. Okay, Susan, go ahead. And if you have an audience question, send it in. We might have a little bit of time to get to it.
Okay, just great presentation. Wondering about the healthcare applications. Maybe be a little more specific about that.
Sure thing. So our application in healthcare is generally specifically medical device manufacturing. And in medical device manufacturing, it's critical to be able to maintain accountability of each and every component of the product, from raw material all the way to delivery to end customer. And that's due to the fact that if there's a defect that's identified, it makes it that much easier to trace the defect to its origins and provide easy recalls. A really good example of that in recent times is everybody ramping up manufacturing for medical device personal protective equipment, such as like masks and gowns, and the shortcomings in their manufacturing processes that have been rooted out, so to speak, due to that. So our technology has the ability to provide an easy and seamless way to make sure that as things are shipped, the appropriate metadata is attached. And so that allows traceability throughout the entire process.
Interesting. Thank you.
Okay, any other questions from judges? Yes, Spencer, go ahead.
Yeah, so I just want to let you know I'd love to chat with you afterwards at some point. And you know, like I said, that's been a huge frustration for us. And I'd be very curious to learn a little bit more. I don't know if we have time right now, but just a little more details about your IP and what the key, I guess, and we used it before, the secret sauce is to that tech that's taking the data, and also what platforms, think about maybe what platforms you've tested this on, what kind of data you're able to process, and creating that kind of a list. Because for potential consumers, that's what we would look at to have potential interest. So just a little feedback.
You've got about 2 minutes if you want to give an answer now, and then certainly you can follow up with Spencer as well.
Sure thing. Chas, I think you would probably be most effective to speak to that. Oh, he's still muted. See?
Thank you.
There we go.
I said I couldn't unmute myself. So with respect to the data collection platforms that we're targeting initially, we're looking at stationary facilities with lots of inputs and a large variety of data. So in the core secret sauce that we have deals with the end-to-end functionality of, we have the field device, we have the communication protocol, we have the data storage, and then we have the custom APIs. So that we aren't piecing together 5 or 6 different systems and making this house of cards or this pyramid of different platforms and technology providers that then we have to rabbit hole down when something stops working and figure out whose problem it is and how we get the solution. So the key piece is the fact that it's built from the ground up and it shares a common platform and a common base.
Awesome. Thank you. Well, we'll give a round of applause to Nexus Reliability. Thank you for joining us. This is our sign language round of applause for those of you joining just now. Thank you so much for joining us here today.